Hitherto we have been solving quadratic equations. And we were getting definite, specific, exact values of x that satisfied this equation. Quadratic equation, second degree equation will give two roots, two values of x. Each value will satisfy this equation. Now we are going to see inequations. This is inequation. Not equal to 0 means greater than 0 or less than 0. Not equal to 0 may mean greater than 0 or may also mean less than 0. These are called inequations. We are going to deal with such inequations hereafter, greater than 0 or less than 0. Better not to say greater than 0, better to say ax square plus bx plus c positive. Greater than 0 means positive numbers only. So it is better to read ax square plus bx plus c greater than 0 or better to read ax square plus bx plus c positive, ax square plus bx plus c negative. Now for solving quadratic equations or for solving quadratic inequations there are several methods. Several methods including graphical method also, which we are not dealing with here now. Quadratic equations and inequations all can be solved by graphical method also, by sketching graphs of the quadratic equations or quadratic inequations. We are not dealing with graphical methods today. We are going to see how otherwise we shall solve such inequations. See the first of these questions. Actually, first question itself should clarify the entire work, the complete method of dealing with inequations. However, I will be solving a few others also. Let us proceed. Factorization of trinomial. Factorization over. The rough work that I am going to show now matters a lot. Please concentrate. X minus 3 equated to 0 gives x is equal to 3. This is the rough work, not to be shown in the solution but for your understanding only. We shall mark these numbers on a number line. This is a number line starting from minus infinity and stopping at plus infinity or merely infinity. My numbers will be plotted here somewhere. 0 is somewhere in between, minus infinity, negative numbers this side, left side of 0, positive number this side, right side of 0. 0 is not marked because we don't require. We require only 3 and 7. Let us mark 3 and 7. The values of x given by this are marked on a number line, creating intervals for you. Minus infinity to 3, one interval, 3 to 7, another interval, 7 to infinity, the last interval. So after solving the equation, I mean to say inequation, factorization gives you values of x to be marked on the number line and intervals are to be mentioned now. Please see here, I am writing. Minus infinity to 3, first interval, 3 to 7, second interval, 7 to infinity, last interval. The intervals. Once again, quickly I am telling you, a uniform method, a uniform method for solving inequations. Trinomial factorization leads you to certain values that can be marked on a number line as I have shown, and mention the intervals that are now created because of marking those values: minus infinity to 3, 3 to 7, 7 to infinity. Marked values are marked. Please see now. For x belonging to the first interval, I will take any number in this interval. What are the numbers in this interval? So many numbers are there: 2, 1, 0, minus 1, minus 9, minus 100. So many numbers, or 2.9, 2.8, 2.7. Many numbers are here this side in the interval minus infinity to 3. I am not crossing 3. I am below 3. Any number I can take. Let us take 1. Rough work, please see once again. For x is equal to 1, substitute here x minus 3 into x minus 7. This is minus 2. This is minus 6. This gives you positive value. Check up the work. 12 or something is not mattering. What matters is sign, positive or negative. For x belonging to this interval, my expression x square minus 10x plus 21 becomes positive in this interval, as you have seen. Now move to the next interval, 3 to 7. Three to 7, you can take any number in this interval: 4, 5, 5.3, 6.9, 3.01. Any number you can take in this interval. I am taking 4. See here. Substitute here. 4 minus 3, 4 minus 7. This is plus 1. This is minus 3. It is giving negative value. So this is negative. Move to the last interval. Any number 8. You can take 20. You can take 100 even. Any number in this interval, I am taking 8. Substitute here 8 minus 3, 8 minus 7. Plus 5 plus 1, that is positive. Intervals are over. My work also is almost over. You require x square minus 10x plus 21 to be positive according to the question. So you have to see where we get this particular thing. We get this particular thing in 2 intervals. X square minus 10x plus 21 is positive in the first interval and also positive in the last interval. We have to now write, therefore, for x square minus 7x plus minus 10x plus 21 to be positive, x must lie in this interval minus infinity to 3 or 7 to infinity. Understand clearly. After factorization, after choosing the values, this is all rough work for your understanding and for your correctly writing positive or negative. Once you have come to know we require positive values, choose positive values here, minus infinity to 3 in this interval or 7 to infinity in that interval. The remaining, the expression given x square minus 10x plus 21 is positive. Lastly, please note, had it been an equation x square minus 10x plus 21 is equal to 0, we would get values of x. Here you don't get values of x, here you get intervals of x. So inequations will give you intervals, equations will give you values. Please note that. Equations will give you roots of the quadratic or values of x in the quadratic, but inequations will only determine the interval in which the particular inequation holds good. Solving one more question, let us take number 2 itself. Negative, okay, negative. Factorize. Factorization. Values are x is equal to 2, x is equal to 3, mark the intervals. X is equal to 2, x is equal to 3. The intervals are minus infinity to 2, 2 to 3, 3 to infinity. As before, study each interval now. First interval for x belonging to the first interval. X minus 2, x minus 3, as I have told you, in this interval you can assume any value. I am assuming 1. See here, this is rough work once again. For x is equal to 1, 1 minus 2, 1 minus 3, minus 1, minus 2, positive. This is rough work. I am reiterating, this is rough work, please note. So, in the first interval, it is positive. I didn't want to write x square minus 5x plus 6 so many times, so I have taken e. You can take y, or you can keep the expression as it is in the previous question. Proceed for the next interval. Two to 3. In between 2 and 3, you can take any number 2.1, 2.5, 2.9. You can take any number. I am taking 2.2. Substitute here. This is giving you 0.2 plus. This is giving you minus 0.8 minus. Understand the subtraction and addition of decimals here. 2.2 minus 2 is 0.2. 3 minus 2.2 is 0.8, that is minus 0.8. This is giving you negative. So, E negative. Last interval. 3 to infinity. Take any number, say 6. Any number. Substitute here. Positive. Intervals have ended. My discussion and study in each interval is completed. Let me see what the question requires. Question requires x square minus 5x plus 6 to be negative. This is a plus 6, please correct it. X square minus 5x plus 6 negative. Complete work. Negative is only here. Therefore, x must belong to the interval 2 to 3 for x square minus 5x plus 6 to be negative. This is your value. You have seen just now, only in between 2 and 3, this is giving you negative values. Others are positive values not relevant to the particular inequation.